Hello, hello, hello. Can you hear me? Yes. Hello, my dear students. How are you? Anybody? In the last class, we started studying that we studied. Third topic we started. We'll try to understand more about atomic weight. Yes, good evening. Good evening. Good evening. Arpita, can you hear me? Is the board visible to you? Visible to you? Yes, yes. Yes. Atomic weight. Said that atomic weight, because atom cannot be isolated. Atom is small and it cannot be isolated. ಅಂದ್ರೆ ಅರ್ಥ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಅಟಮ್ ಬಹಳ ಸಣ್ಣದದ ಮಾಡಿದ್ರು ಅಂದ್ರೆ ರಿಲೇಟಿವ್ ಮೆಜರ್ಮೆಂಟ್ ಅನ್ನ ಮಾಡಿದ್ರು. ಇದು ಇನಿಷಿಯಲಿ ರಿಲೇಟಿವ್ ಮೆಜರ್ಮೆಂಟ್ measure absolute mass of it. There are two types of measurement: absolute measurement and relative measurement. Initially, so there was no standard method of measure. Standard is chosen. Standard is chosen. So the initially different standards were used. For the first time, atomic weight is a ratio. It is the ratio of what? If you take hydrogen as the mass of one atom, one atom of an element, mass of one atom of hydrogen, mass of one atom of this hydrogen is considered as a lightest element. Therefore, hydrogen standard was used. Right? After 1960, another standard. That standard we call it as 1 by 1/12 of mass of one atom of carbon 12. Right, 12 here, carbon 12 isotope. Last class we were talking about isotopes. Atoms having same atomic number but different mass number, they are called as isotopes. Like hydrogen has got 3 isotopes having same molecular. For example, hydrogen 1,1 is one isotope, is another isotope. Means they have at the bottom, generally elements are symbolically represented. Z stands for atomic number. Nowadays, A stands for atomic mass. Atomic mass of 1, 2, 1, 3. They have same atomic number but different atomic masses. They are called as isotopes means members. Isotopes. Carbon isotope was taken as a standard. 1/12 of mass of one atom of carbon isotope. So therefore, atomic weight after 1961 is a different standard. We considered new standard. This atomic weight, according to the modern atomic weight, is given by mass of one atom of an element divided by of mass of carbon 12 isotope. Carbon 12 isotope. Are you getting me? That is called as atomic mass unit. You can write atomic weight as atomic weight is given by simply as mass of one atom of any element, mass of one atom of any divided by one atomic mass unit is taken as 1 mu, mass of one atom of carbon 12 isotope. This can be obtained by mole concept. Andre ಈಗೇನು modern concept ಏನು ತಗೊಂಡಾರ? Wait. I will change it. Now check. Are you hearing me correctly? Your voice is not hearing clearly. Now check. Now check. Can you hear me? Can you hear me correctly? Hello? Can you hear me? Okay. Now let us continue. Now how to calculate this one atomic mass unit? One atomic mass unit is nowadays considered by SI unit. This is 1 mu is equal to 1/12 of mass of one atom of carbon 12 isotope. Means we can simply define as atomic weight is equal to mass of one atom of any element. Mass one atom of any element, mass of one atom of any element divided by 1 AMU, atomic mass unit. Now the question is, how can we get atomic mass unit? What is the value of it in grams? For that you need to understand what is mole concept. You know that there are 7 fundamental units. The 7th fundamental unit is mole. Now what do you mean by mole? Like mole is nothing but like 1 dozen is equal to 12. Similarly, 1 mole corresponds to 6.022 into 10 raised to 23 entities. Entities means whatever it may be. Like you can 1 dozen, you can take it as banana. You can take 1 dozen means 12 pence. Similarly, 1 mole corresponds to 6.022 10 raised to 23 entities. This number 6.022 into 10 raised to 23 was is in the honor of it was Avogadro who calculated this value called as Avogadro's number. What it is called as? Avogadro's number. Right? That is called as the concept of mole. Later you will be learning, therefore I am teaching you now only. Means one mole of any element if you take, this number is called as Avogadro number. We represent this number as Na. A stands for Avogadro, N stands for number. Henceforth, whenever I write Na, you understand that it is Avogadro's number. Very important number in the mole concept. Means what? These entities, 1 mole of any substance may be equal to 6.022 into 10 raised to 23. It may be atoms if you take element. It may be molecules if you take a compound. It may correspond to electrons. It may correspond to protons. It may correspond to neutrons. 1 mole is of entities means maybe an atoms. When you take element ತಗೊಂಡ್ರೆ ಅಂದ್ರೆ number of atoms ಇರ್ತಾವ, compound ತಗೊಂಡ್ರೆ ಅಂದ್ರೆ molecules ಇರ್ತಾವ, electrons ಅನ್ನು ಹೇಳ್ಬೋದು, 1 mole of electrons ಹೇಳ್ಬೋದು, 1 mole of protons ಹೇಳ್ಬೋದು, 1 mole of neutrons ಹೇಳ್ಬೋದು. Like 1 dozen pen ಹೇಳ್ಬೋದು, 1 dozen banana ಹೇಳ್ಬೋದು, 1 dozen apple ಹೇಳ್ಬೋದು, 1 dozen students ಹೇಳ್ಬೋದು. Similarly, in to measure the amount of the substance, seventh fundamental unit is introduced by SI. This is called as mole. Okay. Now, if you take, right, if you take 1 mole of carbon-12 isotope, 1 mole of element, if you take, it consists of how many? How many means 6.022 into 10 raised to 23 atoms. Because element consists of what? Atoms. If you take a compound, it consists of what? Molecules. Okay. If I take, what is the meaning of mass of 1 atom of carbon-12 isotope? What 12 stands for? 12 grams. Means 1 mole of carbon-12 isotope means, right, number of atoms, present in 1 gram atomic weight of means you can say 12 gram of carbon. If you take a 12 gram of carbon, it consists of how many atoms? 6.022 into 10 raised to 23 atoms. Are you getting me? Meaning is that the mass of 6.022 into 10 raised to 23 atoms of carbon is equal to how many grams? 12 grams. Then what will be the mass of 1 atom of carbon-12 isotope? Can you calculate using simple mathematics? Let me rub this part. Right? See, what you are going to understand is, we are going to calculate mass of 1 atom of carbon-12 isotope. Meaning what? 6.022 into 10 raised to 23 atoms of carbon will have the mass. How many grams? 12 grams. Then 1 atom of 6.022 into 10 raised to 23 atoms of carbon-12 isotope will have the mass of 12 gram. 1 atom of carbon-12 isotope will have how much mass? Simple mathematics. Nodri. Hang bartada. Then what is the mass? This, therefore, mass of 1 atom is given by mass of 1 atom of carbon-12 isotope is equal to, generally whenever you take like this, you have to take this to the denominator. You will get to 6.022 into 10 raised to 23. Here, whatever you are writing first, andre ಇಷ್ಟು ಅಟಮ್ಸ್ ಮಾಸ್ 12 ಗ್ರಾಮ್ ಇದ್ರೆ 1 ಅಟಮ್ ಕಾರ್ಬನ್ 12 ಎಷ್ಟು ಮಾಸ್ ಇರ್ತದೆ ತಗೊಂಡಾಗ ಈ ಮೊದಲು ಬರ್ದಿದ್ದನ್ನ ಡಿನಾಮಿನೇಟರ್ ನಲ್ಲಿ ಬರೀಬೇಕು. ಆಮೇಲೆ ಇದು 1 ಅಟಮ್ ಅದಲ್ಲ, ಇವೆರಡು ಗುಣಿಸ್ಬಿಡ್ಬೇಕು. 12 into 1 ನಾ ಹೇಳ್ತಿರ್ತದಲ್ರಿ. ಈಗ 5 ಪೆನ್ಗೆ 50 ರೂಪಾಯಿ ಆದ್ರ 1 ಪೆನ್ಗೆ ಎಷ್ಟು ರೂಪಾಯಿ ಆಗತ್ರಿ? ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಿ? 5 1 ಏನ್ ಮಾಡ್ತೀರಿ? ಡಿನಾಮಿನೇಟರ್ ನ ಬರೀತೀರಿ ಇಲ್ಲೋ? 50 divided by 5. 5 1s 5 10 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ ಇಲ್ಲ? ಈಗ 5 ಪೆನ್ಗೆ 50 ರೂಪಾಯಿ ಆದ್ರೆ 1 ಪೆನ್ಗೆ ಎಷ್ಟು? ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಿ? 5 ಅನ್ನ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಬರೀತೀರಿ, 50 ಅನ್ನ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ಬರೀತೀರಿ. ಹಂಗನ ಈಗ ಮಾಸ್ ಆಫ್ 1 atom ಆಫ್ ಕಾರ್ಬನ್ 12 ಐಸೋಟೋಪ್ ಎಷ್ಟದಪ್ಪ? ಮಾಸ್ ಆಫ್ ನೋಡ್ರಿ 1 atom ಆಫ್ 6.022 10⁻23 atoms ಆಫ್ ಕಾರ್ಬನ್ 12 ಐಸೋಟೋಪ್ ಮಾಸ್ ಎಷ್ಟದ? 12 ಗ್ರಾಮ್ ಅದ. ಹಂಗಾರೆ 1 atom ಆಫ್ ಕಾರ್ಬನ್ 12 ಐಸೋಟೋಪ್ ಮಾಸ್ ಎಷ್ಟಿರ್ತದ? ಅದನ್ನ ತೆಗಿಬೇಕಂದ್ರ ಫಸ್ಟ್ ಬರ್ದಿದ್ದನ್ನ ಡಿನಾಮಿನೇಟರ್ ಬರ್ಬೇಕು. ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ರಿ? 5 ಡಿನಾಮಿನೇಟರ್ ನ ಬರ್ದ್ರಿ, ಈ 12 ಅನ್ನ ನ್ಯೂಮರೇಟರ್ ನ ಬರೀಬೇಕು. ಈಗ ಈ ವ್ಯಾಲ್ಯೂ ಏನ್ ಬಂತಪ್ಪ ಅಂದ್ರ 12 divided by 6.022 into 10⁻23 ಗ್ರಾಮ್ಸ್ ಬಂತು. ಅದನ್ನ ಇಲ್ಲಿ ಹಾಕಿಬಿಡೋಣ. ಇಲ್ಲಿ ಹಾಕಿದ್ವಿ ಅಂದ್ರ ನಮಗ ಮಾಸ್ ಆಫ್ 1 atom ಆಫ್ ಕಾರ್ಬನ್ 12 ಐಸೋಟೋಪ್ ಸಿಗ್ತದೆ. ಓಕೆ, ಐ ಹೋಪ್ ಯು ನೋಟೆಡ್ ದಿಸ್. ಲೆಟ್ ಮೀ ರಬ್ ದಿಸ್ ಪಾರ್ಟ್. ನೌ ಐ ವಿಲ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಹಿಯರ್. ಹಾಗಾದ್ರೆ 1 ಅಟೋಮಿಕ್ ಮಾಸ್ ಯೂನಿಟ್ ಅಂದ್ರೆ ಏನು? 1 ಅಟೋಮಿಕ್ ಮಾಸ್ ಯೂನಿಟ್ ಇನ್ ಗ್ರಾಮ್ಸ್ ತೆಗಿಬೇಕಾಗ್ಯದಪ್ಪ ಅಂದ್ರ 1/12 ಆಫ್, ಇಲ್ಲೇನ್ ಬರ್ತೀವಿ ನಾವು? 1/12 ಆಫ್ ಮಾಸ್ ಆಫ್ 1 atom ಆಫ್ ಕಾರ್ಬನ್ 12 ಐಸೋಟೋಪ್. What is the mass of 1 atom of carbon 12 isotope? 12 divided by 6.022 into 10⁻23. 12 divided by 6.022 into 10⁻23. 12 cancels. You can get now 1 upon 6.022 into 10⁻23. ಈಗ ನೋಡ್ರಿ, ಈ 10⁻23 ಅನ್ನ ನ್ಯೂಮರೇಟರ್ ತಗೊಳ್ರಿ, 10⁻23 ಗ್ರಾಮ್ಸ್. ಈಗ ನಾವು 1 upon 6.022 ಡಿವೈಡ್ ಮಾಡ್ರಿ, ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ಡಿವೈಡ್ ಮಾಡ್ರಿ. ಲೆಟ್ us check what do you get. Calculate. You will get the mass there. Yes. Now you can take 1 divided by, have the calculator with you to do calculations quickly. 1 upon 6.022, its value is 0.166. You can take into 10⁻23. And if you shift decimal point 1 place to the right, then what you have to do? Then you have to subtract or add. Right shift 1.66. Write it in the scientific notation. 1.66. If you shift it to the right, then you have to subtract -23 -1. Now what do you get? You get 1.66 into 10⁻24 grams. Look at here. This is a small mass taken as standard, right? Suppose that you are asked to get, right, 1 AMU. Are you getting the idea? Okay. So that is the value of, we'll remember this one as 1 atomic mass unit. Nowadays SI suggested this as 1U, means relative mass. Unified mass, U stands for unified mass. You can note down the facts. Just now we calculated, the value is given by, in grams, 1.66 approximately into 10⁻24 grams ಅಂತ ಹೇಳ್ಬೇಕು. Are you getting me? Okay, right? This is a atomic mass, right? Atomic mass of that is 1 atomic mass unit is given by 1.66 into 10⁻24 grams. Are you getting me? So you can get the absolute mass by using this. This is called as 1 AMU, 1 atomic mass unit. Okay, so that is about atomic mass unit. So generally, whatever atomic mass you are getting in the periodic table, if you observe the periodic table, atomic mass of hydrogen, if you see, mass of hydrogen. If you see, what do you get? You will get 1.008 U. It is called as unified mass. Are you getting me? It is 1.008 U, unified mass. It is 1.008 times heavier than 1 AMU. Are you getting me? 1.008 times heavier than 1 atomic mass unit. Therefore, it is close to 1 AMU. Are you getting me? So, this particular mass generally obtained, whatever atomic masses are expressed in your periodic table, so they are decimal numbers. Why they are decimal numbers? Because whatever atomic mass is expressed in it, it is average atomic mass. Average atomic mass. Average atomic mass. Atomic mass of all isotopes. Of all isotopes. Generally, every element will have isotopes. Right? This average of the atomic mass of the all isotopes is calculated and it is written. Whatever atomic mass you are getting for a hydrogen, it is the average atomic mass of 3 isotopes of hydrogen. One is called as hydrogen, another one is called as deuterium 1,3. We call the hydrogen. ಇದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಪ್ಪ ಅಂದ್ರೆ ಪ್ರೋಟಿಯಂ ಅಂತ ಕರೀತಾರೆ. ನೆನಪಿಟ್ಕೊಡ್ರಿ, isotope of hydrogen with atomic mass 1 is called as protium because it contains only 1 proton, and this one is called as deuterium. This one is called as deuterium. Another isotope of hydrogen is called as a tritium. What it is called as? Tritium. Okay, tritium is radioactive. We even write it as P11 protium, D12 deuterium, T13. Of them, tritium is radioactive. Remember, the average atomic mass of all of them are taken and calculated. That is what is expressed in the periodic table. I hope you understood. That is what is expressed in the periodic table. Therefore, whatever atomic masses you are getting in the periodic table is a average atomic mass of it. Okay. Now, how the average can be calculated? I will take one example. We will solve a problem so that you can understand how the average atomic weight is calculated. Take one problem on it. You will understand. Right? Calculate. Take a question. Calculate average atomic mass of carbon from the following data. You may be asked from the following data. Means different isotopes will have different abundance. You take 3 columns: isotopes, relative abundance means a percentage of abundance in the earth crust, and atomic mass. Now there are 3 isotopes of carbon. That is carbon 612 is one isotope. Its percentage is 98.892 percentage is equal to 12 relative abundance. And carbon 613 is also available. Its percentage is 1.108 percentage. And its atomic mass is 13.00335. And there is another carbon 14 isotope. It is radioactive. Whenever I write star, it is radioactive. Carbon dating of old fossils, old monuments is done by using this only. That is 2 into 10 raised to minus 10 percentage. Its atomic mass is 14.00317 is the data given to you. Now you are asked to do what? Now you are asked to calculate average atomic mass. You are asked to calculate average atomic mass, right? What you have to write is relative abundance means percentage. Relative abundance means percentage, right? The formula to get, note down the formula, average atomic weight is given by you can take the formula relative abundance of first isotope into its atomic mass plus relative abundance of second isotope into atomic mass of 1, atomic mass of 2, second isotope mass of 2 plus relative abundance of 3 into atomic mass of 3, atomic mass of third isotope, whole divided by relative abundance of 1 plus relative abundance of 2 plus relative abundance of 3. There are 3 isotopes of carbon here. If 2 are there, you have to take 2. Generally, this is percentage, means sum of all the relative abundance will be equal to what? This much percentage. All the generally percentage will give you the sum what? Relative abundance of 1, 2, 3 gives you totally 100. Right? So therefore, you go on substituting the values now. That is equal to, first of all, we will take, what is the relative abundance of first isotope? 98.892. I will write a 98.892. Carefully learn one problem, you can solve other problems. Into its atomic weight is given as 12. Okay. Plus relative abundance of second is 1.108 into its atomic mass is given as 13.0035. Okay. Third one plus relative abundance is of third one is 2 into 10 raised to minus 10. Very interesting problem. It will improve your calculation. Into the mass is 14.00317 whole divided by, see, relative abundance of 1 is this, and atomic weight of 1 is 12, and relative abundance of second is 1.108 into atomic mass of second is 13.0035 plus relative abundance of third one is this much, 2 into 10 raised to minus 10, 14.00317 whole divided by sum of all the relative abundances is taken as 100 because it is percentage. Now I will give 1 minute time to you. You calculate, that will test your understanding, calculation ability. Yes, you try to calculate, tell me the average atomic mass. Take this problem. Try to solve the problem. First numerical. How do you solve this? Observe, each one of them can be divided by 100. First one can be divided by 100. What you can get? If you divide by 100, you will get 0. Every one, because the whole denominator is 100, therefore you have to divide every term by 100. Then when you divide by every term by 100, can I write it as 98.892? When divided by 100, you have to shift decimal point 2 places to the left. Isn't it? Therefore, let me write it as simply as 0.98892 into 12 plus. Similarly, you divide 1.108 by 100. You have to shift 2 places to the left. Therefore, you get 0.0108 into 13.0035. So that the denominator 100 can be eliminated. Plus 2 into 10 raised to minus 10 into 14 is there. When you divide 14, you have to shift 2 decimal points to the left. You will get 0.1400317. Relative abundance. Relative abundance. Even number of times questions appeared in the competitive exams. And such calculations are lengthy calculations. They will not give. They will give simple calculations. I will solve problems on this also. Now you calculate. Right? First of all, you multiply 12 into this. Then multiply these two. Then you can multiply by 2. Then you can make adjustments so that you can get you studied how to handle 10 to the power. Okay, you take calculator and solve this. Then I will give few more problems on it. Now let us calculate. See, 0.98, 0.98892 into 12 plus 0.0108 into first of all, one by one we will do now. 0.98892. Take calculator and calculate into 12. You get 11.86704 plus multiply these two. Plus multiply these two. 0.0108 into 13.0035. Your answer will be 0.14004378. Calculator. Okay, whatever value calculator is giving, I am writing now. You multiply these two first, then you can think of remaining things. 10 to the power 10. 2 into, do the calculation. 2 into 0.1400317. You are getting 0.2800634. The problem is 10 to the power minus 10. Now the question is, you have to make add this one. That is a test for your significant figures. How do you manage it? Whenever 10 to the power is there, you have to make all of them to the same power. How can you do this? Can you make them, if you shift the decimal point to the right, what should happen? You have to subtract or add. Yes? Shift right or shift left. 10 to the power 10. How you can manage it? You can manage it as say 5. If I express it in the scientific notation, I will shift it to the right. What I get? Up to 7.8. How many places? 6 places. If you shift the decimal point 6 places here. Here also, if you shift the decimal point 6 places, what do you get here? What do you get? Say 5 places, you can do 5 places, 3 plus 4 plus 1, 5 places. What do you get here? If you shift the decimal point to the 5 places, right shift or subtract, you will get what? 5 places, 1, 2, 3, 4, 5. What do you get? 1, 1, 8, 6, 7, 0, 4 into 0.0, 5 places into 10 raised to, if you shift the decimal point to the right, then you have to subtract. Right shift, subtract. You will get what? 10 raised to minus 5. Plus, when you shift the decimal point to 140.78 into 10 raised to minus 5, then how can you make this as 10 raised to minus 5? You can make it as 10 raised to minus 5 by shifting the decimal point to the left, because you have to add 5 to it. There you get a 0 point. You have to shift decimal point 5 places to the left. 0, 0, 0, 0, 4, 0, 5, 0, 2, 8, 00, 6, 3, 4 into 10 raised to minus 10. Then you have to add. Left shift madidre, you have to add. You will get 10 raised to minus 5. Now all of them becomes what? 10 raised to minus 5. Because minus 10 plus 5 becomes minus 5. 0 point, so many zeros you can neglect it. You can neglect it and add only these two. Because 0.000 will be almost 0. Therefore, we will neglect it. You can neglect it and take only these two. If you take 10 raised to minus 5 common in this, 11, 8, 6, 7, 0, 4 plus 144.3.78 into 10 raised to minus 5. Just I am showing you how the addition can be done. Now just you add these two. You have 1186704, right? 0.00. Then put the decimal point 78. Go on writing the numbers. 14043. 14043. Add them. 8, 7, 4 plus 3, 7, 0 plus 4, 4, 7, 6 plus 4, 10, carry 1, 8 plus 2, 10, carry 1, you will get to 12. So finally I get here 12, 0, 0, 7, 4, 7, 0.78 into 10 raised to minus 5. Now shift the decimal point 5 places to the left. Then you get 12.0074778 into 10 raised to minus 5 becomes plus 5. Therefore, it will vanish 10 raised to minus 5. Therefore, your answer will be 12 AMU, 12.00 AMU. So, this is average atomic mass. Whatever atomic mass is given, right? Whatever atomic mass is given, that is obtained by this one. This is unified mass, 12 unified mass. This is how you can calculate using this formula, right? We'll take one problem given in the exercise based on calculation of atomic mass is type 1 problem. Type 1 problem. I have got another problem here. Type 1 problem. I hope you understood. Atomic mass of whatever atomic mass is given there, 12.001, you will get around 12. Okay, average atomic mass it is. What is average atomic mass? I will retain the formula there. You can consider this problem as a type 1 problems in it. Type 1 problems in it. Calculation of type 1 problems in it. Calculation of average atomic mass. Type 1 problem. Average atomic mass. So there is a problem in your textbook. I will take calculate. Take another example. Calculate. Take this problem. It will be asked the average atomic mass of chlorine. The average atomic mass of chlorine. Average atomic mass of chlorine using the following data. Is the first type of problem that appears for 2 marks. Here you can write isotope. Chlorine 1735. Atomic number of chlorine is 17. Atomic mass is 35. Its relative abundance in a percentage they have given 75.77. Then atomic mass or molar mass also it is called 34.9689. This problem is there in your textbook. Chlorine 1737. Its relative abundance is given as 24.23 and atomic mass is 36.7. 9659. Now try this one. You have the formula. What is the formula? Average atomic mass is equal to average atomic mass is equal to average atomic mass is equal to, yes, relative abundance of how many isotopes are there? Isotope number 1, isotope number 2. Relative abundance of isotope 1 into atomic mass of atomic weight of 1 plus relative atomic mass of 2 second isotope into atomic weight of second isotope whole divided by relative abundance or abundance of 1 plus relative abundance of 2. Generally it will be 100. You can write now. You have 75.77 into atomic mass of the first one is 34.9689. Carefully solve. Plus relative abundance of second one is given as 23 into 36.9659 whole divided by sum of the relative abundance will be in percentage, it will be 100. I hope you understood. Now you can do the calculation. Divide every relative abundance by 100. Means you have to shift a decimal point 2 places to the left and this also 2 places to the left. Divide first one by this first one by 100. This second one also by 100 and calculate. This is a problem given in your textbook. May appear for 2 marks. Calculate now. You can get now that 75.77 upon 100 becomes 0.7577 into 34.9689 plus. I hope you are getting me. Yes. Calculate. Hi. Hello. Yes, I am calculating. Just you take calculator, finish it. 0. This is a textbook problem. NCERT 23 into 36.9659. That 100 is divided here. Now use calculator. You can get the relative atomic mass. Relative atomic mass. Yes, calculate relative atomic mass. Yes, what is your answer? You can write your answers in the box, comment box. Yes, it is a textbook problem. 0.7577. Yes, into take calculator 34.9689 plus 0.2433. Check your answer into 36.9659. It is a problem in the textbook. Tell me your final answer. It is 35. My answer is 489,739. Therefore, roughly it is taken as 35. Round it up to 5. Right? Go on rounding off. If you remove this, it will become what? 4. If you remove this, it will become 7. If you remove this, it will become 10. It becomes 9. If you remove this, it becomes 5. Therefore, average atomic mass of chlorine in the periodic table will be written as 35.5 unified mass. I hope you understood the concept of average atomic mass. Okay. This will, I hope you understood how to calculate atomic mass. This is the confusion of many students. They do mistake in it. I hope you calculated. Saurabh, I am showing you calculation. It is a textbook problem. This is the first type of problem on atomic mass. Okay. Then we will move on to molecular weight. Atomic weight you understood how to calculate, and atomic weights are obtained from periodic table. Right? Some of the atomic weights you have to remember: element, atomic weight. Better if you remember some important elements, atomic weight for calculation purpose, very important. Later, while calculation of the from the periodic table you can get it. Atomic masses are available. Atomic mass of hydrogen is by convention taken as 1 for calculation purpose. Atomic mass of carbon is generally taken as 12. Atomic mass of nitrogen is taken as 14. Remember some important elements for calculations. Sometimes they will give, sometimes you must know. Nitrogen atomic mass is, weight is 14. Most commonly used. Oxygen is taken as 16. Phosphorus is taken as 31. Okay. Then sodium atomic mass is taken as 23. Remember atomic masses, some of them you have to memorize because they are needed calculations, for calculations. Phosphorus, chlorine is taken as 35.5 and potassium is taken as 39. Some elements. Calcium is taken as 40 for calculation purpose. Later to calculate molecular weight they are useful. Some elements, at least some elements you must know. Iron atomic mass is 56. Aluminium atomic mass for calculation is taken as 27. Note down them and remember them so that for calculation of the molecular weight is very, very important. Aluminium 27. You already know how to write the molecular formula. Now you are going to learn what is molecular weight. At that time you must know at least some of the elements, atomic masses which are regularly used. Hydrogen, carbon, right? Helium atomic number 4. Right? And most commonly used, okay, iron. I think copper, check, is it 63.3? Copper 63.3. Periodic table. Okay, so at least some of them you remember: carbon, nitrogen, oxygen, iron, aluminum. Okay, most of the compounds. Similarly, we will see this is a rounded off values you have to take during calculation, atomic mass of them, and all these masses are atomic masses. Generally, what is the unit of atomic mass? See, when I say average atomic weight of hydrogen is 1.008 U. So atomic mass is actually unitless because it is a relative number, right? When atomic weight is expressed in grams, it is called as gram atomic weight. What it is called as? Gram atomic weight. The gram atomic weight of hydrogen is taken as 1.008 grams. When expressed in grams, it is gram. Actually, it is not that much. It is a relative number. When atomic weight is expressed in grams, we take it as grams. Therefore, we take it as 1.008 for practical calculations taken as 1. Therefore, atomic weight for calculation is taken as 1 gram. Now, similarly, we can define what is a molecular weight. What is the difference between atomic weight and molecular weight? Remember, so molecular weight is also a relative number, right? So, molecular weight of a molecule of a compound or element is obtained by mass of one molecule of substance, mass of one molecule of substance divided by divided by 1/12 of, again same thing, mass of 1 atom of, mass of 1 atom of, right, carbon 12 isotope. Same definition for molecular weight also, same definition, and this molecular weight is also, your molecular weight is also, it is a, see, molecular weight of a molecule is equal to mass of one molecule of a substance divided by 1/12 of mass of 1 atom of carbon 12 isotope. Suppose, for example, I want to calculate, simply will write it as molecular weight of water. Water, what is the formula of water? H2O is equal to mass of one molecule of H2O. Okay, mass of one molecule of H2O, one molecule of H2O divided by, can I write simply 1/12 of mass of 1 atom of carbon 12 isotope as 1 AMU, 1 atomic mass in it. Just now I explained you. So what a molecule of water consists of? It consists of 2 atoms of hydrogen plus oxygen. Now see the interesting thing. So molecular weight of water, if I want, what I do is 2 times atomic mass of hydrogen, 2 times atomic weight, 2 times mass of 1 atom of hydrogen plus oxygen is 1, therefore 1 into mass of 1 atom of oxygen, can I write it, whole divided by 1 AMU. Okay, observe carefully. This is also a relative number, and when you express in grams, it becomes gram molecular weight. Now let us divide this. What do you get? 2 into, let me divide 1 AMU here, 1 AMU here. What do you get? Mass of 1 atom of hydrogen whole divided by 1 AMU. Okay, plus mass of 1 atom of oxygen, mass of 1 atom of oxygen whole divided by 1 AMU. Observe. Now, just now you studied. Shall I rub this definition? Have you noted it? See, I will repeat. Molecular weight of a molecule of a compound is equal to mass of one molecule of a substance divided by 1/12 of mass of 1 atom of carbon 12 isotope. Therefore, suppose I take molecular weight of water is equal to mass of one molecule of water divided by this expression 1/12 mass of 1 atom of carbon 12 isotope is taken as 1 AMU. Now, what this one molecule of water consists of? 2 atoms of hydrogen, 1 atom of oxygen. Therefore, mass of one molecule of water can be taken as 2 times mass of 1 atom of hydrogen plus 1 into mass of 1 atom of oxygen. Now divide each term by AMU. What do you get? Now molecular weight of water can be easily obtained. I am deriving a formula to calculate molecular weight. Molecular weight of water is equal to 2 times, you can take there, mass of 1 atom of hydrogen divided by 1 AMU. Do you agree with me? I hope you understood. Mass of, already I have written here, plus, okay, already I have written here. Okay, now see, this you understood. I will rub this. We stopped at this stage. Now, just now you studied what this ratio gives you. What this ratio gives you. Mass of 1 atom of an element divided by mass of 1 atom of an element divided by 1 AMU. Mass of 1 atom of an element divided by 1 AMU gives you what? Is it not 2 times atomic weight of hydrogen plus, right, atomic weight of oxygen? Means molecular weight of water can be obtained very easily. Molecular weight of water can be obtained very easily now by using just knowing the atomic weight from the periodic table. You will be given with atomic weight in the periodic table. Either you have to collect it from periodic table, or just now I told you what is atomic weight of hydrogen for calculation purpose, 1, plus atomic weight of oxygen for calculation purpose, 16, and you will get 2 1s are 2 plus 16 is 18 gram per mole, means 1 mole. Or you can simply say that 18U. Suppose that you are expressing it to unified mass, it is 18U. Therefore, we take molecular weight of water as 18U or 18 gram per mole. Okay, this is the simplest way of calculation of molecular weight, right? So you will be asked with the second type of question, type 2 question. I will give some very important compounds. You are using throughout first year and second year. Calculation of molecular weight, calculation of molecular weight, and remember them better if you memorize them. They are helpful while solving molecular weight of a substance. Okay, now you can calculate. I will give you some of the compounds. I hope you understood. To calculate molecular weight by using this formula, you can easily get number of atoms of hydrogen are 2, multiply it with the atomic weight. Then 1 atom of oxygen is there, multiply it with the only 1 is there, therefore 16. 16 plus 2 is 18. Therefore, molecular weight of water is 18. Remember it forever, because they will not change every now and then. For calculation purposes in the stoichiometry, you need to calculate molecular weight. Now take the question. I will give you some important questions. First of all, you write the formula. First one, I will start with hydrochloric acid. We will go to the laboratory. Hydrochloric acid, calculator. Write the formula and calculator. Second one is sulfuric acid. Sulfuric acid. Important compounds used in the laboratory. Calculate molecular weight. Write the molecular formula. I don't know molecular formula. Already we studied in the bridge course. Sulfuric acid. Nitric acid. I will take some acids basis. Nitric acid. You have to write molecular formula, then calculate molecular weight. And remember them forever. Very important. Acetic acid. Acetic acid. Very important. Every now and then you need them. Nitric acid. Fifth one is phosphoric acid. Phosphoric acid. First these 5 you calculate. First of all, you must know the molecular formula of hydrochloric acid. I will start. First one, molecular weight of MOL dot WT of HCl. Now, how many hydrogen atoms are there? That is 1 times atomic weight of hydrogen plus 1 times atomic weight of chlorine. Now already just now I have given you atomic weight of hydrogen is taken as by for calculation purpose 1. That of chlorine is taken as 35.5. Just now we calculated mathematically. Therefore you can write it as 35 plus 1 is 36.5 U, or if it is expressed in gram, 36.5 gram per mole. That is called as molar mass. Means 1 mole of hydrochloric acid consists of these many grams per mole. And second one, you remember them forever. Molecular weight, you can remember molecular weight of HCl. Better if you by heart them. Molecular weight of HCl, because the number of times you require them throughout the first year and second PU. Right, to remember formula. Similarly, you remember molecular weight of at least a few important acids, important bases. What is the formula of sulfuric acid? Molecular weight of sulfuric acid. What is the formula of sulfuric acid? H2SO4. Now you start. You can write 2 times atomic weight of hydrogen plus only one is there, therefore atomic weight of sulfur plus 4 times atomic weight of oxygen. Calculate them and memorize them. Check from the periodic table you have to collect. 2. What is the atomic weight of hydrogen? 1. In the list you include atomic weight of sulfur is 32. For practical purposes we take it as 32 plus 4 times what is the atomic weight of oxygen? 16. For calculation purposes you can take. Now you can get 2 plus 32, 16 4s are 64. Add them. You learn adding. Instead of right to left, you go speed calculation from left to right. How I tell you? Just watch me. Take tens plus, here 60 plus 30 is 90. Then add the unit place, right? You can take 30 plus 60 is 90, 90 plus 2, 92, 92 plus 2 is 94, plus 4 is 98. Atomic mass is 98. When expressed in grams, it is gram per mole. Or when you express in a relative mass, it should be 98 U. Remember, molecular weight of sulfuric acid henceforth as 98 U. Unified mass. Right? That is the second one. Start now nitric acid. What is the formula of nitric acid? Calculate. Molecular weight of nitric acid. That is the second type of problem you come across. Molecular weight of nitric acid. I will give you some important compounds. You come across a laboratory also. They need everywhere. You know, stoichiometry means this one is called as stoichiometry. Measurement. So far you used to learn in the 10th standard only the molecular formula. Now their masses are studied. This study of mass is called as stoichiometry. Now the stoichiometry started. Molecular weight of nitric acid. What is the formula of nitric acid? HNO3. Now start. How many hydrogen atoms are there? Atomic weight of hydrogen plus only one atom is there, plus atomic weight of nitrogen. You can get it. Already I have given you list. Plus how many oxygen atoms are there? 3 times atomic weight of oxygen. Now learn them. Not only learn them, by head them for quick calculation in competitive exams. What is the atomic weight of hydrogen? For calculation purposes is 1 plus what is the atomic weight of nitrogen is 14 plus 3 times atomic weight of oxygen is 16. Now calculate them. 1 plus 14 plus table 16 3s are 48. Now add tens, right? 10 plus 40, 50, 50 plus 8, 58. Mind calculation. 40 plus 10, 50, 50 plus 8, 58, 58 plus 4, 62. 58 plus 4, 62 plus 1 is 63. Unified mass, atomic mass of nitric acid, you can remember. 63. Remember 63 henceforth. You better by heart these important compounds because every now and then you are getting them. Acetic acid. Calculate acetic acid. Number of times questions appear. You calculate because even in the laboratory you need molecular weight calculation is very important skill. After calculating average atomic mass, second type of problems. Calculation of a first year student should have the skill of calculation of molecular weight of a substance given atomic mass. Atomic mass, if it is given, you should calculate. This is second type of problem. Type 2. Calculation of molecular weight of a substance. Fourth one, I given you. Fourth one is acetic acid. Can you tell me what is the formula of acetic acid? You must know. Molecular weight of what is acetic acid? CH3 COOH. You can observe. And even you can write the condensed molecular formula. How many carbon atoms are there? C2. How many hydrogen atoms are there? H4. How many oxygen atoms are there? O2. Are you getting me? C2, H4, O2. Now, you can calculate molecular weight is given by 2 times atomic weight of carbon plus how many hydrogen atoms are there? 4 times atomic weight of hydrogen plus 2 times atomic weight of oxygen. Learn clearly. 2 into what is the atomic weight of carbon? Just now I gave you 12 plus 4 times atomic weight of hydrogen is 1 plus 2 times atomic weight of oxygen is 16. I had some atomic weight of elements used in daily calculations. 12 twos are 24. Remember them, they are regularly used compounds in the laboratory. You need to know calculation. 16 twos are 32. Now have calculation skill from left to right. 20 plus 30, 50. First you add tens. 20 plus 30, 50. 50 plus 4, 54. 54 plus 4. Then unit place you add 58. 58 plus 2, 60. 60 unified mass. Therefore, acetic acid molecular mass will not change every now and then. It is fixed. Like a molecular formula is fixed, its molecular weight is also fixed. Remember molecular weight henceforth. Fifth one, phosphoric acid. Can any one of you tell me what is the formula of phosphoric acid? You are not interacting. But yes sir, no sir, not required. I want your answer. Interact. First few students. Yes. Phosphoric acid. Can any one of you tell me what is the formula of phosphoric acid? Molecular formula. You studied in the bridge course. Note, phosphoric acid is a weak acid. Molecular weight of, I'll give molecular weight. You have to interact of phosphoric acid. Try now. Formula I will give S3PO4. Try now. I will give 1 minute. Don't look at the board. Be interactive. Be interactive. PUC1 students. Be interactive. Now calculator. Don't use calculator. Now we start directly. 3 times directly. What is the atomic weight of hydrogen is 1 plus there is 1 atom of phosphorus. What is the atomic mass of phosphorus is 31 plus 4 times what is the atomic mass of oxygen 16. Now you leave writing like this. Improve. Next level. 3 into 1 3 plus 31 16 4s are 64. Add them. You will get add tens plus first 30 plus 60 90. Left to right you add. You change your direction of addition to speed. Increase the speed. Right, I will give tricks. 30 plus 60 you do in mind. Don't use calculator for simple calculations. 30 plus 60 90. 90 plus 3 93. 93 plus 3 16 4s are 64. Note 93 plus 1 94. 94 plus 4 is 98. 98 unified mass. Phosphoric acid is also having the formula 98 unified mass. I hope you understood. I'll give few more popular compounds. Right? You can try them. Right? Just you are left with 4 minutes time. I will give some 3-4 questions. Sixth one. Sodium hydroxide. You calculate sodium hydroxide. I will give very simple compounds. Sodium hydroxide. Seventh one. Calcium hydroxide. Sorry, calcium carbonate you take. Calcium carbonate. Eighth one. Sodium carbonate. Sodium carbonate. Calculate. Last 3 questions today. You have got left with 3 minutes, 3 formulae. Your time starts now. You are not interacting. You are not interacting. You can use the comment box. Don't use calculator. Don't use calculator. Now you have to write the formula first. Then you have to write. Then you have to write. Yes, sir. Let me see how many of you solved it. Calculator. Sodium hydroxide. Very simple. Molecular weight of. What is the formula of sodium hydroxide? I have given you the list. You can easily calculate. Directly calculate. There is one atom of sodium. Sodium atomic mass is 23 plus unified mass plus oxygen atomic mass is 16. Hydrogen is 1. Remember forever, you will get 20 plus 10, 30. 30 plus 3, 33. 33 plus 6, 39 plus 1 is 40. Therefore, remember, molecular weight of sodium hydroxide is always 40. Like its formula is fixed, molecular weight is also fixed. Better you memorize them. Very interesting, calcium carbonate, molecular weight. What is the formula of calcium carbonate? If you are weak in writing formula, then your stoichiometry goes. Molecular weight. What is the molecular atomic weight of calcium? Is 40 plus carbon is 12 plus there are 3 atoms of oxygen, 3 into 16. Calculate. 40 plus 12 is 52 plus 16 3 is 48. 50 plus 40 90. 90 plus 10 100. 100 unified mass. Remember, atomic mass of calcium carbonate is memorizable. It is 100. Right? We'll practice few more in the next class. You study them. Sodium carbonate. Calculate molecular weight of sodium carbonate. You list them and keep in your diary of molecular weight. As many molecular weight if you know directly, that will save your time of calculation. Sodium carbonate, there are 2 atoms of sodium, 2 into, you must have in your mind, what is the atomic weight of sodium? 23, plus there is 1 carbon, 12, there are 3 atoms of oxygen, 3 into 16. Now you can calculate 23 2s are 56 table. Nodri, hang madbeku 23 table barudilla niಮಗೆ. Hang madri 22s are 40 mind ಒಳಗೆ ಇಟ್ಕೊಳ್ರಿ. 3 2s are 6 40. 23 2s are 40, right? It is 46. 20 2s are 40, 3 2s are 6, 46. 12, 16 3s are 48. Now calculate. Go on adding from left to right. Change your direction. Then speed will change. 40 plus 10. 40 plus 10. Add only 10s. 40 plus 10, 50. 50 plus 40, 90. 90 plus 6, 96. 96 plus 2. 98, 98 plus 6, 1 plus 8, 106. Therefore, molecular weight of sodium carbonate will be 106 unified mass. Whatever calculations I have shown you today, you just by heart them. By heart them I will tell you. Then you can solve numericals very fast. Now onwards, there will be calculation. Don't miss the class. I am teaching you main numerical part which is the stoichiometry part. Okay, that's all, my dear students. If you like Lokji live classes, please join sharp at 6:30 to 7:30. Ask your friends to join. And here it is not a just YouTube channel. I am coming live. It is a course, and test will be taken. Both objective as well as subjective. Questions will be solved both board level and competitive level. Therefore, I have designed it as a course supported by Vedim's app. I will tell you how the app works. Vedim's app you download, improve your mind maths required for NEET, JEE, Karnataka CET or any competitive exam. They are time based. Okay. Have a skill of calculations. That's all for today, my dear students. Tomorrow we will continue with the mathematics set theory. Right. We will try to cover set theory. We will have a test on it. Then we will move on to the trigonometry, which is in or relations and functions will take. Then we will take the